thank you. Thank you for coming. Thank you for being interested in RxJava. And just a few words about my books. If you are starting, there is RxJava Essentials. If you are already used to the concept, I'm writing Grokking Rx with Sasha and another dear friend, Fabrizio. And if you are into custom ROMs, Android, and customization of the whole system, I'm publishing Learning Embedded Android Programming. I'm the organizer of Google Developer Group in Geneva, and I'm full-time Android consultant, and I do even have a girlfriend. So probably I don't sleep. If you for the next hour, we are learning about basic Android reactive programming using the well-known Rx environment right now. A bit of history. Reactive programming was an idea by Eric Meyer when he was in Microsoft, and he released the first reactive extensions for .NET. A couple of years later, in Netflix, Ben Christensen published the first port for the Java virtual machine, and now you have RxJava, RxClosure, Rx Scala, whatever can run on a Java virtual machine. And David Carnock is the man of the moment. He's writing and working on RxJava 2 with a Java 8 support. And he's working on Rx 1, and he's blogging about advanced stuff on his personal blog, Advanced RxJava, and you can check it if you are brave enough after the talk. You will be brave. Reactive programming is based on the concept of data flow. Basically, it's part of the observer pattern, the Gang of 4 pattern, new things. And basically the concept, the main idea is that you are not in control of the data. The data is in charge. You just try to manipulate the data as it, you can think about it as a river. It flows. But we can filter a river, we can merge two rivers, we can manipulate, transform a river as well as for the data itself. It enforces the idea of push instead of pull. We don't ask for the data, we don't get something. We subscribe, and when the data is available, we will get a notification. The notification concept is something that we live in every day. We live with notification. We don't check email every second. We subscribe to new emails, and we get a notification. Same as for WhatsApp. We subscribe to new messages, and we get a notification. Even for a washing machine, we don't check the washing machine every second. We get a ding or some sound when it's over. Rx observer pattern is based on 4 main players. The observable is the one that generates the items and propagate them. The observer is the one that is interested in the data and subscribes to the observable. The moment it subscribes, a subscription object is created. The subscription basically represents the relationship between the observable and the observer itself. The subject is the fancy one of the family, because every family has the fancy one. And if you attended the talk by Sasha yesterday, you know that the subject is at the same time an observable and an observer, and it can be useful in a lot of advanced scenarios, like if you are, for instance, porting a legacy API to some new reactive API. Observable and observer communicate via these 3 methods. Basically, you have on next when a new value is available, on error because things can go wrong, and on completed is fired when there are no elements, no more elements. The sequence is over. We even have a fancy animation that shows how the item propagates. But let's do some Android now. We are working with a standard Android app, like a material-ish, material design app, recycle view, and I'm showing the list of my installed apps. How do we create an observable? An observable is just a standard Java method. We create a method and we return an observable of some kind. For the example, we are using an app info object. To create an observable, we just use the observable.create method, and we do our stuff. And when a new element is available, we just fire the onNext, we pass the element in the onNext, and we are good. In this example, we are looping in a for loop, so we are emitting a sequence of items. When the sequence is over, we just fire onCompleted, and that's it. The thing is, create is very powerful, but it's very tricky, and with great power comes great responsibility, because you have to take care of Rx contract when you use create. You have to check for stuff like people are still subscribed, or if there is some back pressure issue. They are advanced topic. RxJava is an operator for everything, so they provide operators that are more handy to use to create observables. So, for instance, what if we have a list and we want to create a new observable sequence from a list? Observable dot from a list? Be brave. From a list? Oh, attaboy. Observable.from. We pass the list, and that's it. We have an observable sequence of app info objects. Piece of cake. What if I just have 3 elements and I want to emit just these 3 elements? Ah, nice. You're already there. Wait a second. Who's already using RxJava? Please, don't be that guy answering the questions. Huh? Come on. Don't be that guy. Or girl, or lady, or man, gentleman. You got the point. We want to create a reactive extension of a legacy method we already have. So we can create it with the fur and just and passing the method. Or we can be even more lazier and use from callable. It's a new one. They are extending the API over and over. So we can just pass the function, and we have a reactive version of the function itself. Android. Our app is just a recycle view, has an adapter, has a fancy swipe refresh layout. We got the apps list, we subscribe, and we use an observer. What's an observer? It's just an interface. We implement the interface. There are 3 methods. So when we get a new app info object, we add it to the adapter. When the sequence is over, we stop the progress bar and we show a complete toast. When something goes wrong, we stop the progress bar and we log an error, show error toast. It's just a placeholder. And ta-da, huh? But what's the point? We are just filling in a list. You already do list all the time because it's 95% of the apps on the Play Store. We're just fetching data and showing them in a list. The thing is, most of the time, we as programmers, we work with what we have, and with RxJava, we tend to switch to a mindset in which we are not in charge of the data. The data is just coming to us. For instance, we have these incoming apps function. We don't know if it's a network call. We don't know if it's a database call. We just know that it's at least returning an observable sequence that we can use. The thing is, what if our manager comes in with a change request and he wants just items in the list, apps, for instance, with names starting with a C. We are lazy, we want to reuse code, we want not to change the observer because they will still be app info object. How can we filter the sequence and apply some kind of condition? How can we filter the sequence? Yes. Basically, we apply the filter operator, and I'm using a lambda here because I like the little arrow. I'm using Redor lambda because I'm using it for 3 years now. It works even in production on big apps. We don't have Java 8 yet. We are not using Kotlin yet, so Redor lambda, it's the only way to avoid boilerplate. Filter just takes a predicate. It's just a condition. Basically, it evaluates the condition and propagates the item only if the condition is English, please? It's true? Nice. Sorry, I'm from southern Italy. It took me 30 years to learn Italian. I'm still getting there with English. And we have a new a new sequence with names just with a C, with one line of code. We didn't change the observer. The observer is still waiting for app info object, so piece of cake. Too long did you read? Our boss is way too much lazy, and he doesn't want the whole sequence. He just wants a shorter version of the sequence, and he wants just 3 elements in the sequence. How can we take a whole sequence and just take 3 elements? Take 3 elements? Take 3. And we got a new sequence with just the first 3 elements. One line of code. The observer is always the same, and he's just waiting for app info object. He doesn't know anything about the sequence when it will land, so knows nothing. And we will be calling him Chonsno, because reasons. This is the end. We have this sequence. We are not in charge. The data is in charge. So our boss, okay, we got we got change request. He wants just the last 3 elements of the list. So how can we take the last 3? Ish, huh? So we have a new sequence with the last 3 elements and 1 line of code. There are a bunch of operators that we can use. For instance, we don't want duplicate in a sequence. We want to be sure that we are using processing one value only once. How can we achieve that? First thing first, we are working with an incoming apps sequence, and we know that we cannot install the same application twice. So basically, by design, in this example, we don't have duplicates by design. But we have RxJava, so we are creating duplicates because why not? We are taking the 3 elements, we are repeating the observable 3 times. Now we have a sequence full of duplicates that we can work with. How can we filter out all the elements and be sure that there are no duplicates? Distinct, and we have Josno. Distinct will basically work on a complete sequence and will be using the equals to as a comparator or compare to whatever. You can even specify which field you want to compare, and basically will take care of filtering out the duplicates. piece of cake. But it works on a completed sequence. How can we work with an ongoing sequence? For instance, away from the app installed app example, we are working on an IoT project because it's the new cool thing, and we have a current temperature sensor, and is emitting the current temperature every second. So for every incoming value, we are displaying the value on a small LCD display, even if it's the same value. So we are basically, sorry, the Croatian food is kind of challenging. So what what if we don't want to update the display? We just want to update the display with new values. So how? But we can use distinct, but the sequence is ongoing, so we cannot use distinct because it won't work. But we can use distinct until changed, because why not? Distinct until changed will take care of remembering the previous emitted values, and will propagate the new value only if it's actually new. And we have Jon Snow at the wall because it's 25 below. The thing is, we are not satisfied because we don't want to even receive a new value every second, because I don't think that the temperature will change so quickly. So we want to slow down the rate of emission of the original observable sequence. And probably some of you are familiar from their college time with the sample function. We are just created we have just created a new observable. Basically, sample creates time windows with an amount and a time unit, and will mirror the original observable, and will propagate only the last emitted item in the time windows. So in this example, we are having a new element on the last emitted element in a 5 minutes window. We slow down the sensor. If we add distinct until change, we are slowing down even more because we are filtering out the equals values. And we have always the observable. The thing is, we can chain operators. We can always chain operator. That's the mindset switch, the functional way of using or approaching programming. We are applying function to incoming values. There is an operator for everything. So if we want the first element of the 5 minute window, we just use throttle first, because there is an operator for everything. You can even create your own operators if you are brave enough and you actually cannot do what you are doing with the existing operators. So sky is the limit. We can transform a river, we can transform a sequence of elements. Because of our boss. Because it comes in the morning, we have a change request. I don't like capital letters, because why not? It's like kids. Everything must be lowercase, mommy. And we are lazy, and we don't want to change stuff. We want reuse Jon Snow, it's back from the wall. And basically, we need something we can apply to the incoming value, change a bit of things, and emit the value once again. Like something, let's try to apply a function, a map. We are getting an app.info object. We are lowercasing-ish, whatever, the name, and we are emitting the element back with a lowercase name. Same incoming sequence, same observer. We just apply a function to the whole sequence, and we are done. The thing is, map could retard everything. We are working with what we have. What if we have a list of installed apps, but we just want their names? We can take the incoming sequence, we apply a map to extract the single string in the name, and we return the string. At that point, we are creating a new sequence, a different one. Jon Snow will be not able to handle it because he's waiting for a different type of object. So we will need a new observer, but we are creating a new string sequence because we are creating the sequence we need. What if we want the icons, for instance? We will extract the icon and return a bitmap. And we are creating a sequence of bitmaps from whatever incoming sequence we have. And we have a bunch of transforming functions. We have operators for everything. So if we start using RxJava, you start creating a lot of small function that returns observable sequence. If you want to apply that function to a sequence, you will end up with a flat map or a concat map. They are kind of observable equivalent of map. They work with sequences instead of the single element. If you are, I don't know, having a new element and you want to cast it, every element to cast to long, for instance. You want to, change the type. You can use cast. You are not in charge of the data. You are not in charge of the observer. You are the poor guy in the middle. So the observer is waiting for a list of app.info object, and the observable is emitting them separately. How can we do the transformation? We can use buffer. Buffer will mirror the previous observable and create a subset of elements and emit them as a list. So if you are not in charge of anything, working with a theme, for instance, this could be a real case scenario. They are waiting for a list, you are receiving single element, you apply an operator, everybody is happy. Combining, we start working with sequences. So we have two lists. One is the one we are using, and the second one is the reversed version of the list. They are emitting the same type of object. So how can we merge these two sequences? How can we merge them? Try to guess. Be brave. Bye.
Too easy.
No, there's no point too easy operator. Try again. Let's try again. I don't want to participate to your subtle plot. Merge. Bravo. I don't like your attitude. Just answer the question. Merge. Why not? We just merge two sequences. Jon Snow is always waiting for an app.info object. So 2 sequence, 3 sequence. It doesn't just know. It doesn't care. We have 2 different type of observable. Let's say we have our list and we have an observable sequence of long. I don't have the sequence, but I have RxJava, so we are creating the sequence with a dot interval. Dot interval is basically emitting a new long every 1 second in this example. Takes an amount, takes a time unit, just 0, 1, 2, 3 every second. We have a function, so we have 2 observable and a function, and we want to be sure that for every element, we combine them with the function and we emit them. Zip. Zip will combine the latest not zipped element from the 2 sequences and will apply the update title function. And the update title function is still emitting an app.info object because it's just changing the name, prepending the long. So Jon Snow is good to go. Android. We are using RxJava for shared preference example. We are reading from shared preferences. We don't have the list. We store the list as a Mongoose JSON, as a string. We read the string. We parse the list with JSON. We create a list of app info object. We emit the list with onNext. We call onCompleted, and we are happy because we are using Rx. Everything is reactive. Yay! And then we enable strict mode. Strict mode. How many of you use strict mode? Focus. Strict mode comes with the SDK. It's Android, pure Android. It's provided by Google, and it's the Google way of telling you how much you suck at programming. Because the moment you enable strict mode, you will start seeing something like that in the logcat. This read violation. We are reading from shared preferences on the main thread. We are blocking the UI for a quarter of a second. And you're like, come on, I'm using Rx, all the reactive faff or whatever. Yeah, no, because by design Rx is synchronous, because you are powerful and wise enough to manage the tool. I don't want to decide or, having somebody taking care of stuff. I just want to use the tool. So the thing is, we are reading on the main thread, we are blocking the UI, the app is kind of laggy now when we deserialize all the sequence. We should be off the main thread because it's some I/O related operation. And how do we do that? Probably async task is the answer. No. Because we have Rx and it's 2016 and I'm too old to do threading manually. We have schedulers. RxJava provides you schedulers. In this case, we have I/O related operation, so we use a scheduler I/O. Schedulers I/O, it's just a thread pool. Actually, you should even don't care about how they implement the thing because you just want to use them. And everything is open source. So if you are curious, you have a time, you don't like hanging around with people, or you don't sleep, you can always check the source code. The thing is, we are now off of the main thread, and if we run the app again, the app works. We don't have the strict mode violation, but the app explodes because only the original thread that created a view hierarchy can touch its view. Makes sense. We are giving the list to the recycle view, so basically we are reading from disk and sending stuff to the UI. To manage to change the UI, we need to be on the main thread, the UI thread. So it's getting a bit tricky because we need to be on another thread doing the job and getting the result on the main thread to update the UI. Probably the async task is the answer because they have the on post, on pre, on whatever. It's too many years I don't use an async task. But still, we have RxJava and we have something like Observable. We have Rx Android that provides Android schedulers, and that's it. We are basically doing multi-threading with 2-line of codes because we subscribe, we do the job on a scheduler I/O thread, and we observe on, we receive the result on the main thread. Everything that is above the subscribe on, in this example, will be done off the main thread, in the I/O thread, and everything that's below, in this case, subscribe, will be done on the main thread. So we are saving time doing multi-threading with 2 lines of code, and we don't have excuse anymore to be bad at programming and be bad at concurrency. It's not easier, but it's easier, way easier and more practical. So you don't have excuse anymore. Just do the right thing with the right tool. And guys, deal with it. So, jokes apart, what if I don't have a I/O-related task? I have this function that's just emitting a list, but it's doing a very important job. It's a for loop, but it's quite, important. And if we run this thing, we got this. If we don't care about the logging, we still care about the dialogue. It's not nice. We have schedulers, but we have seen scheduler I/O. It's not I/O related because we are, crunching data. We are doing computational work, and you know what? We have computational scheduler because there is an operator and a scheduler for everything. I mean it, everything. If you need something done immediately, scheduler immediate. Why not? I'm not in a rush. Just append the task at the end of the current scheduling queue. Trampoline. If you need a new thread, you feel nostalgic, use new thread. There is a scheduler for everything. Real world, even more real world examples. We are working with RetroLambda because we fell in love with small arrow and other stuff provided by RetroLambda. We are using Butterknife because nobody can write an Android app without a library by Jack Wharton. Because probably just Chuck Norris. I mean, the guy just forked RetroLambda to improve it. So it's, now we have Jake's RetroLambda. Even worse. I'm using Lombok because we are not using Kotlin yet, so I'm too old to do getters and setters manually. Come on, really? We are using Retrofit because it's the only sane way to communicate with the REST API. And universal image loader, you can use Picasso, Fresco, whatever. It's just loading the image. I use this because it works. I'm kind of emotional linked to the thing. This is the app we are going to create. It's a list. Go figure. I couldn't be more creative about the list, but we are fetching data from 2 different APIs because we are retrieving the list of the most used, the most famous developers on Stack Overflow. A round of applause for Stack Overflow because because without Stack Overflow, none of this could be possible. And for every element in the list, we are fetching the CD and we are fetching the current forecast for that CD using the Open Weather Map API. I'm using Retrofit. Are you using Retrofit? Don't you? Or you still doing the HTTP request manually? No. Are you using Retrofit? How many of you are using Retrofit? Jeez. Don't be shy. I get scared, if you don't give me feedback. This is the old 1.9. I'm not on 2.0. There is a wonderful post by Sasha, how to migrate the thing. Thank you, Sasha, for the post because I need it. And I'm using JSON schema to Pojo to basically create the classes by the JSON schema, so I don't have to deal with I'm lazy, I'm old. I just talk to the backend guy, give me the JSON, I pass the JSON, I press play, and the website gives me back Java classes I can paste again, then in the folder. It's okay. You don't have to deal with annotation or Jackson, JSON, expose, whatever. You just pass the thing. We can automate, we automate. We create API manager to keep stuff, organized, and we have a get most popular SO users because naming is critical. We don't get the response we want because the backend is giving us a user's response that it's an Among Us JSON containing a lot of stuff and the list of users, but we just want the list of users. So we apply a map Basically, we call the getUsers method of the user's response object. We extract the list. We do the job on the scheduler I/O. We observe on the main thread, and we are good to go. Android part, we have the adapter. It's just an example. Please don't create stuff in your activity. Use something like MVP or MVVM. Try to decouple and do the Java stuff separately so you can test it. Use Dagger, obviously, if you need to inject stuff. And we have the refresh list method. It's just showing a progress bar, fetching the users. If a user list comes in, update the adapter, stop the progress bar. If something goes wrong, stop the progress bar, print an error, log an error, or some crash lyrics, what you want. And we have half of the project. So now for every element, we do a bit of job on the adapter. View holder, you manage, you got the point. For every element, we are retrieving the city, getting the city, and retrieving the weather for the city. We are filtering out bad responses because we are working with what we have, creating a sequence we want. And during the making of the example, everything blew away because I got a null pointer exception. Weird thing, never happened before. And so I'm filtering out null response. I'm filtering in responses that just are valid. So the list is greater than 0. I'm applying a concat_map function, and with that function, basically I'm loading the image with the library you want. The library is wrapped with RxJava and is returning an observable of bitmap. So you can, create wrapper around legacy code, synchronous legacy code, to use to feed the chain, the RxJava chain. So we retrieve the little icon for the weather. We do the job on scheduler I/O. And when the icon comes in, we are on the main thread, so we can apply the icon, set the icon if the icon comes in, or log an error if something goes wrong. And with 10 lines of code, we are basically fetching data from 2 different APIs. We are completely testable environment because we can test everything in isolation. Every small function that we apply during the chain can be tested in isolation because they are pure Java function. And using what we have, we are creating the sequence we need. It's a mindset switch. Observable sequences are like rivers. You need to think about that you are not in charge anymore because you are used to imperative programming, but you can't use imperative programming if you are dealing with network calls that can take seconds, or database call that could take seconds. So you have to switch and be prepared to, as a behavior, what is going to happen when I receive the data? What is going to happen when the sequence is over? What is going to happen when I got an error? And put everything in place and just do other stuff in the meantime because you are doing it asynchronously. It's an order of magnitude harder than doing the get, but the get, now you have a number, you have an amount of a millisecond that you are wasting doing that kind of programming. You are working with a flow, and you can filter a river, you can transform a river, you can combine 2 rivers, merge them, and they will still flow. In the end, it will be the river that you want it to be. So be water. Thank you, everybody.
And now the famous Q&A. I'm sure
Yes.
you have a lot of questions for Ivan.
Please.
Or not. Do you have some presents?
Excuse me?
I think you said
Oh
you have some presents.
we are picking a few. Actually, we have 100% free copy of the new Grok King RX book, the initial one. So, how many slides I have? How many?
It's a huge presentation.
Jesus. Okay, whatever. If you feel confident that you can approach reactive programming with the last book, we are giving away a 100% discount code. But I want to be fair, so I won't be picking the white male or the lady or the black man or the Asian man. So basically, we are doing Hunger Games, and yeah, it's up to you now. So there is just one ticket, and you just, fight to that if you want it.
Okay, who wants to be the winner?
I'm joking. If you are interested, just drop me a mail and check.
Or ask a question now. Come on,
ask
don't
a
make
question.
that easy
Don't
for
be shy.
them.
Ask a question. There's no Hunger Game
I
involved.
knew you were going to do it. Another question there, okay?
Oh, they're nice.
Hello.
Hi.
First of all, can I borrow your glasses?
Yes.
Later, okay.
Later.
Do you have any comments on back pressure, and did you experience any performance issues by chaining too much operators one on another, transformations and so on?
Yes, I have experience, and it's not that big deal because when you start chaining stuff, at some point you have no chances to avoid it. Somebody is producing data more faster than the old people are waiting for data can process them. For instance, I was wrapping an event listener. At some point, it was throwing data like there was no tomorrow, but we were fetching the data and storing part of them. So the database was the bottleneck. And we were starting losing data on our stress tests, and we solved it with on-back pressure buffer, for instance. So the moment the data comes in, they kind of get buffered. The memory increases, but you are not losing elements, and then it shrinks, and you just handle the sequence. Or if you are in charge of the generating part, you can try to slow down the producer, but it's up to you. It's a scenario, specific. But don't be afraid of operators like on back pressure, or if you don't care, for instance, you can use on back pressure drop, or you can, just save the 5, 10, 20, I don't know. You can provide an amount. Most of the time, you place on back pressure at the right spot, and you're done. Because you are creating the chain. You are supposed to be in charge of the chain, at least. And you know that the database could be the slowest. So.
Yeah, thank you.
Oh, welcome. Easy one. Another easy one, please.
Okay, so if possible, could you explain in 3 simple sentences what would be the difference between flat map operator and the map operator?
The map applies on flat map works with a sequence. For instance, if you are creating a function that creates or returns an observable, in the chain you will have for every emitted element in the original observable will be fed to the function that returns a sequence itself. So you will have like a plethora of running sequences for every element that you are emitting in the beginning, in the original observable. The thing is, flat map can interleave the result. So if you are interested in keeping the order of the results, you will be using concat map. Concat map will do the same thing of flat map, but we will wait until the first sequence is over and chain the result in the sequence, and you will keep the order. Map is just for the single item itself. If you have a function that returns an object, you use a map. But if you are returning an observable sequence, you need flat map or concat map or switch map, merge map, whatever map. There is an operator for everything. Are you satisfied? Yeah. Other questions? Hands? Hands? Good to go?
So now you have to decide who wins.
Oh no, we will do it later. I don't want to spoil the thing.
Okay, Ivan Morgillo, ladies and gentlemen.
Thank you again for having me.